Before we start, I want you to go ahead and start that warm-up and use what we learned in 14.1 to complete that. And then we will be checking the warm-up in class next time I see you. So go ahead and pause the video and do that warm-up. And then when you're ready, press play and we will start 14.2. Okay, so 14.2 is product of power property. So the learning goal, I can generate equivalent expressions involving product of powers. So some vocab. We have 3. So we have product of powers property, we have power of power property, and we have power of product property. Say that 10 times fast. Okay, so product of powers property is when we multiply powers with the same base and we add their exponents. So anytime we are multiplying two numbers that have the same base, so these both have a base of 4, we take their exponents and we just add them together. So 4 squared times 4 cubed gives us 4 to the 5th power. And the reason for that, we can prove it off to the side, is if I actually write these out, so 4 times 4, and then times 4 times 4 times 4, I have 1, 2, 3, 4, 5 of our base, which means I have 4 to the 5th. So with letters, because we also do a little bit of algebra in here, if our base is the same, so even if it's a letter, we just add our exponents together. And you'll see that in a few of our examples. So when we have power of power property, we find the power of a power by multiplying the exponents. So anytime we have a power, or an exponent, like a base to a power of a number, and then we bring that to another power, it just means that we multiply our two exponents. So we do 4, in this example, 4, and then times 6 to the 3rd, or 6 times 3, which gives us 18. So now it's 4 to the 18th power, or the power of 18. Same thing with algebra. When we have a letter as the base, we still multiply the exponents together if it's being raised to an exponent. A power of product property is when we find a power of a product. We do this by doing the power of each factor. So we're going to bring and distribute this power to the 5th into both things within the parentheses. So now that 5 goes to the 3 and it goes to the 2. Same with when we use letters. It makes sense once we start doing it. So let's look at example 1. So example 1, we have the same base. We have a base of 2. And we're doing 2 to the 4th power times 2 to the 5th power. So that means that we just take our base, we keep our base the same, and we add our exponents. So 4 plus 5 is 9. And then that will be my answer. And then if they want you to actually simplify it, you'll do 2 to the power of 9. And we get 512. So here, again, we have the same base. And the reason it's the same base is because this is just one of them. So it's like having the power of 1. And then this is telling us that the negative is with the 5, which matches our 1 on the outside. So we have negative 5 to the 1st power times negative 5 to the 6th power. So, we're going to add that we keep our base the same, but we need to put it in parentheses. And then 1 plus 6 is 7. So I can simplify that even more now by doing 5 negative to the 7th power. Rather large number. So we get negative 78,125. And that's my final answer for that one. So now this is the algebraic form I was talking about. And so you'll see we have the same base. And so we have the same base, so we keep the base, and then we add our exponents. So 3 plus 7, we are going to add those, and we get 10. Now we can't simplify this one anymore because we don't know what x is. So this just remains x to the 10th power. So now I want you to try product of powers on your own, and then you will check your answer with mine.